Hey guys, it's Miss Barber again, and today we are going to be talking with pre-algebra about scientific notation. Now, this could also be applied to Algebra 1 because this is a skill that we continually use, not just in math class, but in science classes. It's called scientific notation for a reason. Now, scientific notation is a way for us to take really big numbers, and either like incredibly large or incredibly small numbers, and write them in a manageable form that everybody can understand. And it makes it easier to manipulate mathematically when you're in upper level math classes. So what we're going to do today is we're going to talk about how to put a number into scientific notation and how to put a number from standard form and how to put a number in standard form from scientific notation. That's all we're going to do in this section. So let me get my pad set up here. There you go. All right. Now, to put a number in scientific notation, we've got to look at specific things. The first thing we want is we want one number, 1 through 9, in front of the decimal. We also are going to be counting the places we move the decimal. Okay. So now, part of this is scientific notation is a number in decimal form times something, times 10 to some power. And counting the decimal allows us to move things back and forth. And if you think about it, if I have the number 1.2 and I multiply it by 10, what happens to this decimal? Well, 1.2 times 10 is 12. So it moves that decimal over 1. But if I have 1.2 times 10, and this is 10 to the 1, 10 and 10 to the 1 are the same thing. 1.2 times 10 to the negative 1, that becomes 1.2 times 0.1, which gives me 0.12. It moved it this way. So that's knowing which one's positive and which one's negative is going to help us out. Now, a rule you may want to think of. If it has a positive exponent, on your power of 10, it is a really big number. If it has a negative exponent, it's a really small number. Okay, so let's start this out. If I have the number 64,000, the first thing I want to do is I want to have only one number in front of my decimal. Well, my decimal's starting out here, whether it's written in or not, that's where it starts. But in my scientific notation form, I only want one number before that. So I'm going to look if I need to move my decimal here between the 6 and the 4. So when I rewrite this, it becomes 6.4 times 10 to some power. Well, let's see, this is a big number, so it's a positive exponent. And I moved it 1, 2, 3, 4 spaces. So 64,000 becomes 6.4 times 10 to the 4th. Well, what if instead of 64,000, it said 64 thousandths? See, that's tens, hundreds, thousandths. Okay, 64 thousandths. That TH on the end is a big difference. Well, I still want my decimal between my 6 and my 4. But this time, this is a small number. It's a decimal number. It's a number smaller than 1. And I'm going to move it back 2 spaces. So it becomes 10 to the negative 2. Okay, so if it's a really big number, I had a positive exponent. If it's a really small number, I had a negative exponent. So let's look at a couple more. 2,320. where does my decimal go? Well, I want one place past the decimal. It's going right there. So I write 2.32 times 10 to the 1, 2, 3. Okay. If I have 4,350,000, where does my decimal go? That doesn't change anything. It still goes right here between the first two numbers. So this becomes 4.35 times 10, 5, 6. Let me count that. 1, 2, 3, 4, 5. I moved it 6 places. Okay. If I have, I don't know, let's see, 0.000000152. Okay. Where does my decimal go? It goes between the 1 and the 5, because that puts one number in front of my decimal. Now, this is a little number, so it's going to have a negative exponent, and it moves, the decimal here moved 1, 2, 3, 4, 5, 6 places. Now, it's really important to pay attention to whether it's a positive exponent or a negative exponent, because both of these have 6 as an exponent. But the difference between negative 6 and positive 6 is really big when you look at what you're talking about in terms of our numbers. Okay. So now we're going to go on to what it looks like to, so this part's not too bad. Going from standard notation, which is this, what this is called, to scientific notation is not too bad. Now, where a lot of people struggle is when we go from scientific notation to standard notation, because we have to do everything in reverse. So let's see, if I start out with 5.3 times 10 to the third. Well, let's look at our clues. What does this tell us? Well, this positive 3 exponent means it's going to be a big number. So I want to make it grow. I'm going to be adding zeros to the end of it to make it bigger. So if I start out with it, 5.3. Now I want to make it grow. So I want to move that decimal. And here this tells me I'm going to move that decimal 3 times. So 1 I've got. 2 and 3 are empty loops. Well, remember, we're multiplying by 10. And if you're multiplying by 10 and you have empty loops, you just add zeros. So 5.3 times 10 to the third is the same as 5,300. Okay, let's try another one. 1.45 times 10 to the fifth. Okay, so I start out with 1.45. Positive exponent means I'm going to grow, going to go this way. Okay, 1, 2, 3, 4, 5. So 1.45 times 10 to the fifth is equal to 145,000, because I put my little comma right here. Okay. Now what if I had 3.7528 times 10 to the third? Okay, well, let's look at this. We'll write out our initial number, 3.7528. 10 to the third means I'm making it bigger. I'm moving that decimal to the right to make it bigger. I'm moving it 1, 2, 3 times. So my new number is 3,752 and 8/10, or 0.8. So does scientific notation always move it all the way away and give you zeros? No, you have to be careful with your counting. So all these have been positive exponents. Not too bad. Well, let's look at some with negative powers of 10. 8.7 times 10 to the negative 4. Okay, negative 4 means we want to make it smaller. It means we want to take this decimal and slide it the opposite direction to make this number an even smaller decimal. So I've got 8.7. I need to move it 4 times, but this time I'm moving it to the left to make it smaller. 1, 2, 3, 4. My decimal goes here. I've got to fill in 3 loops with zeros. Now, some people like to put a 0 in front of the decimal, some people don't. That's where a lot of people get confused sometimes, is when we've got to figure out what goes around that decimal. But if you remember, positive exponent, big number, negative exponent, little number, that's going to help. So if I say 1.35 times 10 to the negative 7, okay? This negative 7 right here is my power of 10, tells me I've got to move my decimal to the left. So I start out with 1.35, and I have to move it 7 times to the left. 1, 2, 3, 4, 5, 6, 7. It feels awkward moving to the left, but there we go. We filled each of our loops in with a 0. So we go from our scientific to our standard notation. So let's see, let's try another one. 2.76 times 10 to the negative 6th. Negative exponent means we're sliding to the left. So now we've got 2.76, and we need to take our decimal and we slide it 6 to the left. 1, 2, 3, 4, 5, 6. That means I got to fill in these 5 empty loops with zeros. Okay? And it's always awkward writing backwards, as you can see. But the big thing to remember when we're working with scientific notation and putting numbers into scientific notation and taking numbers out of scientific notation is we have to count very carefully whether we're putting it in or taking it out, okay? Now, I'm going to put a couple of problems down at the bottom. 2 are going to be to go from standard notation to scientific notation, and 2 are going to be to go from scientific notation to standard notation. At this point, I want you to pause it. After I put up the problems, I want you to pause the video. Take your time, work the problems. Once you've finished working the problems, start the video up and I'll have the answers for you. So go ahead, I'm going to tell you what the problems are and then give you a chance to work them. So first we're going to go standard to scientific notation. And I want you to take 5,378,000, and then I want you to take 0.000832. I want you to put both of those from standard notation to scientific notation. And then I have 2 I want you to take from scientific to standard. So I want you to take 6.375 times 10 to the 5th and put it in standard notation. And I want you to take 8.23 times 10 to the negative 8th and put it in scientific notation. Okay, on your own paper, go ahead and do this. Pause the video while you do this to give yourself time to work them. Okay, once you've finished, go ahead and start the video again so you can check your answers. So now let's look at this. I've gone through Now, I want my decimal between my 5 and my 3 because I want one number in front. So this is 5.378 times 10, big number, so it's positive. And I moved it 1, 2, 3, 4, 5, 6 places. Okay. I look at the next one. I want the decimal between the first two numbers, which means a number. In this case, when I'm talking about a number, I mean a numeral between 1 and 9. So 1, 2, 3, 4, 5, 6, 7, 8, or 9. That's what I want in front of my decimal. So I put the decimal between the 8 and the 3. Now this is a small number, so it gets a negative exponent. And I moved it 1, 2, 3, 4 places. Okay. Now, any more questions on this? If you do have them, go ahead and put them in the comments. I'll do my best to check them and reply, okay? Or you can email me if you're one of my students and you know my email address. All right. Let's look at the next one, 6.375 times 10 to the 5th. I'm going from scientific to standard. So I start out with my number. It's a positive exponent on my power of 10. So I'm taking my decimal to the right. 1, 2, 3, 4, 5 places. So now my answer becomes 637,500. 8.23 times 10 to the negative 8. Negative 8 means we are going to the left because we need to make it smaller. It's a negative exponent, so it's a small number. So I have 8.32, sorry, 23. And I'm backing up 8. 1, 2, 3, 4, 5, 6, 7, 8. Fill in my blank loops with zeros, and I'm done. It's really easy to go find more practice on this. All you really have to do is go to Google and put in scientific notation practice worksheets, and all kinds of things will come up. Please practice, try this. It's not a skill we use very often, but it's an important skill. And when you move to Algebra 1 and higher classes, not only do you have to be able to do this, you have to be able to take these numbers, add, subtract, multiply, and divide them. So get good at this first before we add anything to it. If you have any more questions, please feel free to message me, put something in the chat box, just let me know. Be safe and all that other good stuff. I'll see you all again on our next video.